Good morning, y'all. Anyone tired after spring break? Because I am feeling tired. Okay, so today this video is going to go over evaluating logarithms. So we're given some logarithms and we're going to figure out what they're equal to. So quick reminder of what logarithms are. Logarithms are the inverse of exponential equations. So remember that the base of a log, think of that as the base of some number raised to an exponent. Logarithms are equal to whatever that exponent is. So logarithms always equal an exponent. Always equal an exponent. And it's going to be the base raised to that exponent c gives us some number, and that's what we're taking the log of. So let's go down here to look at number 1. The base of the log is 9. So we're raising 9 to some power. And we're going to have to think about what that power is, and we want it to equal 81 because that's what we're taking the log of. So base goes there, taking the log of 81, so that's what the exponent is equal to. So we need to figure out what is that exponent. And in this case, we know that if we raise 9 to the second power, we get 81, right? 9 squared equals 81. So our answer is 2. Look down here at number 4. Remember that if you don't see a base written, it's an invisible 10. Logs without a base are always written as log base 10. So we need to think 10 raised to what power is 1. Anything raised to the 0 power is 1. So actually, anytime you see that we're taking the log of 1, the answer is always going to be 0, no matter what the base is, because whatever the base is, if we raise that base to the 0 power, the value is always 1. Okay, so we're seeing how to get what exponents to use to get this number. So look at number 3. 4 raised to the something power equals 64. Equals 1 over 64. We're getting a fraction for this. That means that our exponent has to be a negative number. In this case, that negative number is 3. Recall that when you get a negative exponent, you can get a positive exponent, or rather what you should do is move that number into the denominator so that you get a positive exponent. 4 raised to the third power is 64. So since we were taking the log of 1 over 64, we were trying to get our exponent equal to 1 over 164. So that means our answer is -3 for that one. Cool. Look up a number 2. I'm going in a weird order here. Invisible 10. 10 raised to the what power is 1 over 10? This is just a simple -1. We're just flipping that 10, that base of 10, into denominator, and then that makes the 10 positive, or the 1 positive. Sweet. So logs always equal to exponents. In some cases, though, we are going to have to change the base because the original problem might not make sense. So let me show you. If we do a base of 125, that's not 125, raised to some power, we actually can't do this, right? We can't raise 125 to a power and get 25. We can't raise it to something and get a number that's bigger than 125. So what we're going to have to do is change the base. Well, actually, here, let me rewrite that. So the base is 125 raised to some power, and it needs to be equal to 125. Remember from our exponent rules, we're allowed to split this up by finding a number that we can raise to a power that will give us 125. So in this case, 5 raised to the third power is the same exact thing as 125. And then we just add that x in there. That x that was in the exponent before. I'm writing this as an x because remember that logs are always equal to exponents. So we're trying to figure out what that x is. We're going to need to get 25 in the same base. We want to change that so that it's a base of 5. And now we can set those exponents equal to each other because they have the same base. So our exponent is 2 over 3. I know that's weird, but it's okay. Sometimes exponents are fractions. Cool. So I think number 6? I think number 6 is the same way. I haven't actually worked this out ahead of time. But our base is 64. We don't know what the exponent is, and we're trying to have it equal 1 over 16. So I know I'm going to have a negative exponent, and I'm going to have to change the base, and I'm probably going to have to change this so that I get them in the same base. So I'm thinking what numbers times itself equals 64? So maybe 4, and 4 to the third power equals 64. We've still got that x up there because that was the exponent before. I should probably be writing them like this. This will make this make more sense. Right, we changed 64 to 4 to the third, and then that exponent was still outside. 1 over 16 is the same as 4 to the negative 2. Let me back up. 1 over 16 is the same as 1 over 4 squared. And so converting that back to a negative exponent gives us 4 to the negative 2. So now we can set our exponents equal to each other. 4 to the third raised to the x power, there we go, equals 4 to the 3x. So we are setting those exponents equal to each other to figure out what our log is equal to. And in this case, it's negative 2/3, so even weirder than our last one. So just to be like super redundant, 64 raised to the negative 2/3 power. Oh, I was using the wrong colors. 64 raised to the negative 2/3 power equals 1 over 16. Okay. There's 2 more to go over. Sometimes we're not solving for what the log is equal to. In this case, this base of 9 raised to the third power will tell us what we're taking the log of. So base of 9 raised to the third power. What's 81 times 9? 9 times 9 times 9. 729. Is that right? 9 times 9 times 9. Yep. So, base, exponent, what we're taking the log of. So x equals 729. And then in the next one, the base is what we're solving for. So x raised to 2, remember logs are equal to exponents, equals 100, because that's what we're taking the log of. So in this case, 10 squared would equal 100. So x equals 10. All right, that wraps up this video. We will do some more work with this in class. Hope y'all are having a great day. See you later.